Here's the bottom side of the Digital Control Center where you can see everything. Just giving it a quick once over while I'm down here. There's a fuse here that I check out. Looks fine. Obviously when I'm here I'm going to be cleaning switches, so here's a switch right in here. Now I'm just going to be spraying that with some contact cleaner and cleaning that out. Nothing abrasive, just a nice cleaning to get any of the bar smoke that has accumulated on that switch over the years off of it. This basically has 3 boards on it, and then there's some components that are actually on the chassis as well. These 2 blue things here are Mylar capacitors. Although they're very large, they're actually only 0.22 UF. So they're fairly small when it comes to capacitors. I'm not going to worry about those. The Mylar ones tend to not go bad over time, only with use, and I'm concerned more about the capacitors that go bad just simply because of their age, not because of the amount of hours they've been used. So anyway, I'm not going to worry about these 2, unless maybe someday I will buy some and replace it, but right now for the preventative maintenance I'm worried more about replacing the big electrolytic foil capacitors. So this little board, I look at this one, it has a little tantalum on it, which is a 1 UF 35 volt if I remember right. I'm going to replace that one just because I have replacements for it. I'm not going to replace these ceramic discs. I looked on the back side of them, looked at the top side. Visually they all look fine. Nor am I going to replace this this Mylar here as well. It's probably good. I will give it a good examination, but not planning on replacing anything on that board. I'm going to leave it alone. This board here, it too does not have any large capacitors on it. It only has a few of the smaller ceramic discs. And someday I will buy a slew of ceramic discs and go and replace them on, because they use a ton of these on the various Seeburg products. So, but I'm going to remove this one. It's held on just by pulling up on the little 4 corners of it and gently removing the connector. That'll get me down to the one that I need to do the replacing on. Alright, I removed this board and giving it a once over. It actually looks like it's in really good condition. Don't see any bad solder on it. I don't see anything that's smoking. So visually it looks like it's in really good condition. So I'm just going to set that one carefully aside. Here is what we're needing to work on. Okay, so you've got capacitors that on this one look apparently original. Maybe that one's been a replacement, but not the rest. The rest of them are all these Siemens and Spragues, which were original on this box, which was what, 1970, 71. So these kind of capacitors do get old with just time and age and wear out because they're electrolytic foil. So it is time to replace them, even though they might be working just fine now. I want to just go ahead and take care of it. So I got 1, 2, 3, 4, 5, 6, and 7. Of course, while I'm in here, I will look at other things just to make sure everything looks fine. Like the fuses are all looking okay. Alright, time to remove this board. Again, it's held in by 4 corners and then gently unplugging the... Okay, now for the fun part. I'm going to be removing and replacing capacitors. I'm going to give you some handy tips here real quick as I go through this. Hope if you're an old hand at this, obviously this is all going to be really boring. You can just skip everything. But if you're new like me, this might be helpful because I've had a lot of lessons learned, some the hard way and others from very, very helpful people on the yahoo.com groups Seeburg forum. Just some very, very helpful people there. Taught me a lot so far. Looking for years to come on that. Anyway, also, I think my brother, he lent me this ESR meter here, a fabulous tool. I wish I owned one. I'm gonna save up and buy one. They're about $110 right now. This is an Atlas ESR model 60. The newer one is a 70. But what I like about this is you can test all electrolytics and tantalums, meaning that you can check everything with that's 1 UF and larger. Doesn't test the real small stuff, but it tests 1 UF and larger. It gives you both the capacitance and, more importantly, the ESR value. ESR value is basically what builds up inside of it. It's a resistance, and that's what makes these things go bad, because you can actually have a capacitor that has the right UF or with intolerance, but the ESR is built up so great that it's causing it to fail. So this is a tester for that. I'm just going to show you real quick. I don't really care what the old ones are on here because I'm replacing them, but if I didn't want to replace them, I could check them. I checked these a couple months ago, and a couple of them were reading high, or a borderline going away, but they all worked. But like, here's the replacement ones, and I checked the replacement ones because I've had bad new replacement capacitors. You buy them and they're a piece of junk. So how do you know? You got to check them, or else you put all new ones in and it doesn't work, and you're complaining and wondering what the deal is. So here's one, and it doesn't matter which end is plus or minus on this, because they're both black, and it's real simple. You just hook it up and you push the test button, and it tells you this capacitor is 324.8 UF with an ESR of 0.04 ohms, which is a great capacitor. It's well within tolerance. This capacitor is supposed to be a 330. So I marked that down on this sheet. I made this sheet up it's a real simple Excel spreadsheet. And I'm going to put this out there on the file section of the Yahoo Seeburg groups if you want to download it and use it. But basically, I have a difficult time keeping things straight when I'm looking at the Seeburg manual. So I just went in and I just said, okay, real quick, what's their part number? What type is it? Whether it's when I say ceramic, I mean it's one of these discs right here. They're kind of brownish looking, or black I guess as well. But they're these flat discs. They're called ceramics, or mylar. This is a mylar here. They're the things that often look like cough drops. And then tantalum. There's not a tantalum on this board. It's on the other board. But a tantalum is a real small, round little guy. And so there's a 1 UF tantalum 35 volt. And then the rest of these are the ones I'm replacing. These are the lytics. These are your electrolytic aluminum foil capacitors. And so it has one that's a 10 UF 50, 150, one 20 UF 50. Then it's got 3 of them that are 100 UF 35 volt. These are all volts. These are UF. And then one that's a 350 and one that's 1050. And so you try and get them as close as you possibly can on the UF. And volts are, when you replace it, it's either the same or greater. So like for instance on this, well, I'll show you as I go. So anyway, so this is the big guy. This is the 150 right here. And that one I'm going to be replacing, I'm at 100, excuse me, it's 1050, 1000 UF 50. And I'm going to replace it with a 1000 UF 63. So it's okay to replace it with one that is the same volts or greater, because that's just the more volts the better. Obviously you don't want to replace it with a 300 volt, but anything that's equivalent to or greater on the volts, you want to be plus or minus 20% if at all possible on the UF, which is also called in the olden days MFD. Now they call it UF, same thing, because this one will say UF on it. That says MFD, same terminology, different letters. Alright, I was able to find, and I try and find if I can afford them, these axial ones. There are 2 kind of capacitors that they have out here for this. There's axial, which means there's a lead coming out both ends, or a radial, where both are coming out of one end. All the old Seeburg ones are axial, so I tend to buy these axial ones, but they're harder and harder to find. Very few people use them anymore, so it's a lot cheaper to buy the radial ones. Anyway, if you take a look, and they also get a lot smaller. I mean, look at the difference in size. You know, that basically apples to apples there. Problem is when you get down to it, on these big ones especially, you got the holes. So it's going to go in the board here and the board there. And so on this one, I bent the leads already, you can see it, so that one's going to fit okay. But on this next one, which is the 300 UF, let me show you this real quick. I mean, that is much smaller, and the holes that are on the board, the circuit board, where you got to put it in. I know hole isn't the correct terminology. There's no way I'm going to do that. Plus, this thing, if I do it, this is going to be sitting upright, and another board just happens to be sandwiched on top of this board. This board here sits on top of that board, and so I don't want this sitting up too close to it, because I don't want it rubbing on the bottom of that one. So I got to bend this one over a bit. When I do, I'm running out of lead. The leads on the new one are not long enough to fit on the circuit board. So in this case, which is good before I desolder, I'm actually going to clip this one and just solder onto that lead. So that way I think I have I/O by it. If not, I'm going to have to unsolder one of these and actually put another lead on there. But I think if I had, darn it, I don't know if that's going to make it or not. We'll find out. But I may have to I'm going to alligator clip this together, solder that one, alligator clip that, solder that one, and then hopefully it will just sit there nice and pretty and fit. We will soon find out. But that's one of those things you got to look at beforehand. Just don't go on soldering things, or else you're going to be wishing you hadn't later. The great thing about the newer Seeburg boards, by the way, is they did a great job of actually labeling the positive on them. So you can see on every one of them, they label the positive. They don't label the negative, so that there's no way that someone could think of positive as a negative, because they only label the positive. And look on the back side, they did the same thing here. So here's that one. Where am I at? Right there. That's the positive, and that's the negative for it. And they've even put the number on there, and I know you can't read them because it's upside down. So this one that I'm just clipped was C05, and on the schematic it was called C3105. So it's easy to find, easy to know what you're doing. So hopefully I won't goof it up too bad. So that's that. So that's the only one that's going to be really of a challenge as far as the distance. These 300s in the middle, you can see that I'm going to be able to replace that with these Panasonics and just sit them right in nice and straight up. So that'll fit in real. That'll be an easy change out. This little 22 UF 50 volt, it replaces that one there. And so that'll be an easy thing to pop in. It'll just sit up right like that when it's done. This last one, this Leland capacitor is going to go right in here, and this is a 10 UF 100. And so my replacement on this one, this was rated at originally needing a 10 volt 10 UF 150 volt. And so the one that I was able to find online is a 10 UF 160 volts. So as long as it's equal to or greater, which is greater, that's just going to be fine. So that's going in that spot. So there you have it. It's time to start desoldering. My desoldering tool, my brother showed me this, and I absolutely fell in love after I used it. This is a Radio Shack desoldering tool, and it's like $13, and they actually stock it on their shelf. Believe it or not, they actually stock electronics in a Radio Shack still. parts and things. And this is, I would never buy a capacitor from there, but this is a great tool. You just put it on the joint, let the bulb suck down, let it up, it sucks the solder right inside of there. Then I just spit the solder out onto an old ad and go on to the next one. It works great. That way you don't peel up any of the pads. When I first started doing this, nobody told me, of course I didn't look hard enough either, I would have learned, is that if I try and use a regular solder iron to take the solder off, you can't really do it. And then you leave a little bit of solder in there, and when you're trying to pull it off, it actually will tear the solder joint that's on the board. They call it a pad. It'll tear it off, and then you don't have anywhere to solder to. So then I went to a local electronics store and bought one of these solder suckers. That's this little spring-loaded thing that you gotta, it's like a really big pen, and you push it down and it clicks and it sucks the solder up that way. That was a real pain, especially all the caulking, and it didn't work well. So this is just a handy tool if you want to spend $13 on a great investment. It saves you cussing, it saves you a lot of problems. That's what I would do. I just want to show you how good this solder sucker does. I just put it on here, and you'll know when it melts. I let go of the bulb, I pull it off, and you can see that joint right there. Right there I just did. Nice and clean. I just go over here and I just blow this old lead out. And remember, lead is not good for kids, so I blow it on a piece of paper, trash the paper. Also, these leads get bent over, so I can actually use the end of the solder sucker as I go to bend them up a bit so that they're easier to get out. Give it a second suck just for good measure. So look at this, watch how fast this goes. You wait till it melts. You'll know when it melts. As soon as it does, you let go of the bulb. There it goes, right there. Easy peasy.